Yo, 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 yo. All right, ladies and gentlemen, we're going to be talking about similar figures today. So we're going to work with transformations and determine if something is similar or if it's congruent or what the difference is. So similar means that we have the same shape, but not the same size. So same shape, not the same size. So if I took a triangle, okay, and let's say I took that exact same triangle. I just made the exact same triangle, and I translate it, and I reflect it, and I rotate it. It is still congruent because it's the exact same size and shape. But as soon as I shrink it down, or I make it larger, it is no longer congruent because now we change the size of it. As soon as we change the size, it's still the exact same shape, so it still has a triangle with 3 sides, it still has the same angles, but the difference is now it's larger, so therefore it's just a similar figure, where all the sides are still in the same proportions to one another. It's just that now it's a different size, so therefore it is these two triangles are similar to each other, they are not the same. So whenever we perform a dilation of any kind, our figures are no longer congruent, but instead they are similar. So basically, this is combining everything that we've been doing. We're going to combine a bunch of translations. And then once we combine all those translations, we're going to talk about whether or not the angle is still congruent or if it is still similar. So we're going to go in order here and just take it one step at a time, and we're going to write the letter with our transformations based on what we just did. So first I have my original rectangle. Now I'm going to translate it by adding 7 to x and subtracting 2 from y. Well, if I add 7, 1, 2, 3, 4, 5, 6, 7, subtract 2 from y, 1, 2. So I just translated that bottom right point, so now I'm just going to redraw the shape here. Let's see, this is 1, 2, 3, 4, so 1, 2, 3, 4. Make sure I did that right, yeah. Okay. That's me trying to draw a rectangle very poorly. So there's A. I'm done. Now I'm going to take that, and then I'm going to, looks like I have to flip it across the x-axis because it's telling me to change the sign of my y value. Whenever I change the sign of y, I'm going from positive to negative y. That means I'm reflecting it over the x-axis, and that's what we're going to do for B. So let's see, we're 1, 2, 3, 4 away. So 1, 2, 3, 4 away, and then I'm just going to redraw it. Let's see if I can do a better rectangle this time. Not terrible. There's B. Now for C, rotate 90 degrees clockwise. So 90 degrees clockwise rotation is going to end up over here. Okay, and then I got to swap my x and y. So for this one, 1, 2, this is at positive 1, 1, 2, 3, 4. So that means I'm going to be at negative 4, 1, 2, 3, 4, negative 1. So that gave me this point. So now if I rotated it, it's going to be, everything's going to be like this one's at 6, so it's going to be at 6. And then I can just redraw it. Now I know it's 1, 2, 3, 4. So there's rectangle C after a clockwise rotation, 90 degrees about the origin. Okay, next, it looks like it's going to have me translate it 5 to the right and 3 up. So let's take 1 point. 1, 2, 3, 4, 5. 1, 2, 3. So I took this far right point, so I just got to redraw it again. 1, 2. 1, 2, 3, 4. Well, look at that. That's kind of nice. It's right over the origin is right in the middle there. So shape D. And then finally for E, it's going to have us dilate it by a scale factor of 3. So I'm taking these points and I'm multiplying it by 3. So this point right here is at, let's look at this point. This point's at 1, 2. So if I multiply that by 3, it's going to be at 3, 6. So that's 1, 2, 3, all the way up here at 6. That means this is going to be a negative 3, 6. This one's going to be at 3, 6, 3, 6. I'm actually going to draw this one with some lines here because I know I will mess this up pretty badly. That's a lot better. And there's my final one because I had a scale factor of 3, so I tripled the size. And there is E. Okay, so if I list the coordinates of vertices E, we know that they're at -1, 2, 3, and +6. And we're at every combination of 3 and 6. So I'm also at +3, +6. I'm at +3, -6, and I'm also at -3, -6. All right, so now what we're going to do, so we did all these transformations, right? So A, B, C, and D are all congruent. They're all congruent to each other because we didn't change the size. As soon as we dilated it on E, now we're at a similar shape. So this means this rectangle is the exact same proportions. It's still a rectangle, still have the same angles. So that means it's similar, but it's not congruent because it's larger. So if I compare the shape of rectangle E to the original figure, the shape, it's still a rectangle. If I compare the size, it's larger by 3. Okay, so E is larger. The angle measures are all still 90-degree angles. Angle measures are what are the angles here, here, like what are our angle measurements? They're all still 90-degree angles because that's a rectangle. So it's just a little bit larger. All the angles are the same, it's still a rectangle, so therefore this and this are similar figures. Okay, so describe what happens to a figure when the given sequence of transformations is applied. So here I have one transformation, then I have a second transformation, and then I have a third transformation. So here's what's going to happen. Whatever this figure is, I'm going to reflect it. Okay, this is a reflection. Then this is a dilation because I'm multiplying each point. Looks like we're going by less than 1, so I'm shrinking it. So this is a reduction. Reduction means make it smaller. And then finally, we're doing a translation. So if we were to describe what happens to a figure when the given sequence of transformations is applied, I would write those things. I would say that figure is reflected, it is then dilated and reduced in size, and then we slide it and translate it. We now have similar figures. Okay. Now also what you're going to have to do is you might have to look at two different shapes, and you might have to determine how to get from one to the other. So identify a sequence of transformations that will transform figure A into figure B. Tell whether the figures are congruent or whether they're similar. So right away we know that they are not congruent because they're different sizes. Okay, we know that they are similar. Now what we need to figure out is how do I figure out what the scale factor is to get from here to here. The best way to do that, so because of the fact that this was also translated, I can't just pick a point. Because it was translated, because I would have to multiply this and it's going to make it bigger around the origin, but then I got to move it around a little bit. The best way to figure out what that scale factor is look at the side length. This is 1, 2, 3, 4. This side length is 1, 2. Well, as we did with finding our scale factor is we take whatever the new point is and we divide it by the old. Well, we can also do that with side length. So my new is 4 over 2. That means the scale factor was 2. So we took A and we have to multiply it by 2. That's my scale factor, that's my dilation. Because when I multiply it by 2, it's going to bring everything out to 2s because these are all at 1. Now we're at the same size rectangle, right? I mean, sorry, this is a square, not a rectangle, Gridius. Now I'm at the same size square. Now once I dilate it by a scale factor of 2, I'm going to abbreviate scale factor. So that's the first thing we do when we identify a sequence of transformations. Then I'd have to slide it. So I just got to pick a point, figure out how much I have to slide it. To get from here to here, I got to slide it up 1, 2, 3, 4, 5, 6. So that's going to be y plus 6. And then 1, 2, 3, 4, x plus 4. So once we dilate by a scale factor of 2, we perform a translation by moving it up 6 and right 4. Okay, and these are similar figures. So this would be the actual answer. Here's my sequence of transformations, and then I'm telling whether the figures are congruent or similar. They are not congruent, but they are similar. And that's because they're different sizes. Okay, guys, that's really it. There's nothing else for this one. So the biggest thing is just recognizing the difference between similarity and congruence. Okay, nothing for your things to remember, but please get the independent practice done. And that's all I got for you guys. Thank you for watching. Good DS out.